So this is the second lab we are recording, and it's about Newton's second law. And we're going to demonstrate that with the Atwood machine, or a simple pulley, which two masses are hanging on either side. And we will change the force acting on one side to calculate the acceleration. So, as part of your pre-lab, we have this Atwood pulley that has a mass M, small m, and a big M, capital M, on this side. As a result, you would know that because of the force of gravity, this side is going to be accelerating. There's force acting on this side. Obviously, there is a force acting on that side. So the net force is on the side of the capital M, and this whole thing is going to accelerate downward on this side, and it's going to accelerate upward on this side. The acceleration should be the same on both sides. One is the opposite side of the other one. Okay? So what you're going to do is writing the free body diagram for the mass M on this side, and also writing the free body diagram for the small mass M on that side. So once you get those free body diagram, you will find the net force acting on each side and write down the equations, and from there you should be able to find the acceleration in terms of the small mass, big mass, and the gravity. Acceleration due to the gravity, G. Okay? So this is the pre-lab. Okay? Then, for the actual experiment, we are going to first keep the total mass of the system constant. And we are going to find out how the acceleration and F net are related by just taking a certain amount of mass from one side and adding it to the other side. That way, the total mass of the system is going to be constant. However, the net force on the side that has more mass is going to increase, and obviously the acceleration as well. So you're going to plot acceleration versus F net for this case, and answer the questions in your lab handout. The second part, we are going to vary the total mass, but we are going to keep the net force constant. Okay, how do we do that? Well, first we start with 100 gram on both sides, but we incrementally add, say, 10 or 20 gram on both sides. Okay? So, by adding the equal amount of mass on both sides, we keep the F net constant and vary the total mass. Of course, one side has to be has more mass than the other one overall, so that the system would accelerate. Okay. So we start, say, with 100 gram on one side and 120 on the other side. So it's going to accelerate on the side of the 120 gram, and we just add increment of 20 gram on both sides. That way we keep the F net constant, but the total mass is. So then you plot acceleration versus the mass, and you would analyze that and find out the question that are asked from you from that plot. Okay, so this is basically the essence of this experiment. There are other questions that you would have to answer based on the observation and the experiment data that we capture and provide to you. Okay, we have 100 gram on both sides of this pulley, and I'm going to, right now all the forces are balanced, so I'm going to take 10 gram from one side and add it to the other side and let go and let the capstone capture the velocity. Okay, the second trial, I'm going to take 20 gram from this side and add it to this side and go. Whew. So this is the second part, and we are going to vary total mass of the system, but we keep the net force on one side constant by adding the same mass on both sides. So right now I have 50 gram on this side and 60 gram on this side. So I'm going to let go and make the measurements. So right now I have 60 gram on this side and 70 gram on this side. Ready?